So, just as a way of background, have any of you come across learning style audits? It's what you do, things when you do continuous professional development and you do your Myers-Briggs and you do all your other things to find out what you are. Has anyone done a learning style audit here? Yeah, so some of you know what it is, so I should really get you to explain it, shouldn't I? When we learn, as some people like to sit down and read the handbook from cover to cover, then do it. Other people just plug it in, switch it on, and fill it with volts and see what happens. And that's a learning style. And I will probably be at the end of the spectrum where let's just plug it in and see how many volts it takes before it starts smoking, rather than the sit down. And with data science and some of the things that's going with it, I've been at another number of presentations like you probably have, saying how this is a brave new world. But I want to know what it is. I want to press the go button and see what actually happens. And so what we're going to do today is that I'm going to give you a little bit of background. In the slides that are here, I'm going to show and are already available on SharePoint, there's a number of documents that are embedded in it, including the data I'm going to use. So in theory, in an hour's time, you should be able to go away and do what I've done with the data I've done it with. And that may be a success or not, but we'll give it a whirl. So the expectation I'm lowering is I'm going to do this live in front of you, and I've never done this live in front of an audience before. So there might be a few oops moments, and does anyone see on the screen where I'm meant to be pressing? Because the first thing I've noticed is my screen's gone a bit haywire trying to get this in, and all my buttons have disappeared, but hey, let's just work with it for a moment. Oops. Yeah. Okay. Right, let's get cracking. You're all happy with that? Yeah. You're all up for it. Fasten your seatbelts. So what I'm trying to do today is we've had a lot of talk, and this is coming from the top down, that we've got to transform the way the NHS works, and we've got to become a data-rich society, and we've got to use our data to achieve maximum benefit. Those of us that have been around for a bit have probably noticed this is washing over from the American coast, because America, as you know, is very much into big toys and big experiments and big everything, and they believe big data is going to solve all their problems. Time will tell. But we're on the same train journey they're on. So we are trying to explore how we can help doctors and nurses deliver better healthcare by taking some of the hard work off their shoulders, by using the data we have available and using it in a more intelligent way. So what it means for us is the sort of things that we've been doing, extraction and presentation of data, and doing some analysis in terms of SPS, SR, things like that. That will seem like a very old-fashioned way of doing things in hopefully 10 years' time, and what we're at the beginning of the journey of where that all becomes very industrialised. So what I'll go through in baby steps today is how we actually start that journey. How do we start turning some of the rhetoric into actually how we are actually going to deliver some of these things? And so hopefully you will be given confidence at the end of this that it can be done. I'm just going to show you the video, which you've probably all seen on television, but just to set the scene. Oops, it's on that one, isn't it? Does this seem familiar to you?
Artificial intelligence helps us meet the needs of today, so we're prepared for tomorrow.
By 2050, we need to produce 60% more food. So how are we going to feed the world without wrecking the planet? Using Microsoft Artificial Intelligence, we can reduce waste and produce more food. Any grower will tell you every row, every crop is different. We can use Microsoft AI to make local predictions about light, wind, rain. It just helps farmers know when to plant, irrigate and harvest. It's making a difference.
Artificial intelligence helps farmers grow more while wasting less.
Nice use of a cello there. You've all seen adverts like that, haven't they? They're bombarding us on television at the moment. And what we've got to try and do is work out how we get from that aspiration And Microsoft are very much in the healthcare industry. I think it's one of their core 5 business areas. I'm looking for nods, something like that. They've got 5 areas that they want to extensively improve their market penetration, and healthcare is one of them, which is why they're pushing a lot of these things at the moment. Can we deliver on this? And that's the question that we're probably going to answer today. Interesting note, for those that have a statistical background, a lot of the statistics we now use, especially the sort of testing statistics, were developed before the Second World War to show how to increase crop production. So the fact that Microsoft are using the very same analogy, I don't know if they realise that we've already been there, but anyway, we'll come. And also, just as a side note, being a allotment gardener, if they think having something stuck up in the middle of my allotment is going to produce my crops, they've got another thing coming, because I can tell you it's the slugs that get it every time. But anyway, I'm just going to dip into, I'm going to talk about Azure because of 2 very simple reasons. Machine learning comes in lots of different flavours. You can go into many different packages to do it. Dr. Watson, as I'll come back to later on, is probably the market leader in this in some respects, but you have to download their package to try it out, and we can't download anything onto our computers. Azure can work off the internet, and it's free for anyone that's got an NHS England login for 1 year. So what we're using today is the free login. Just as a note, Azure comes as the major platform. It is a web hosting platform, isn't it? Yes. So if you're an international bank, your web services may be on Azure. Azure ML is actually not on the same site. It connects to it, but it's on a different site. So you've got to look for Studio ML, that's what you Google, to get into this site, because I can tell you, if you think you're going to get to here by coming from the main site, you've got another thing coming. So that's, if you just go into that landing page, Studio Azure ML.net, you can Google it. This is what you get. You get lots of interesting information. You get lots of interesting videos about how to get started, which is essentially what I'm going to be doing today, and a whole lot of references. And then it says, do you want to try it? So you press sign in, it asks for who you are, and once you've done it once, and you're logged on to SharePoint, it knows you're a SharePoint user. Spooky, isn't it? So you never have to log on again if you've got a SharePoint account. And coming through the Wi-Fi, there you go. We're now in the Azure machine learning environment. I'm going to come back to this in a minute. I'm going to show you how, there you go, there's some of my models. It's getting a little bit slow because we're on the Wi-Fi, but and that's all there is to it. Get to the landing page, sign in, press the button, and away you're going. It's as simple as that. Let's just get back to here. I'm just going to go through a little bit of background just to set the scene of why we're doing this. And this will help to, I think, sort of get you to know what it is we're actually trying to achieve. So where does this all come from? Well, as I said, it's very much driven by America at the moment, and it's very much driven by us as consumers being identified and our needs and wants better matched. And I'm going to make a few examples of that. But there we are. There's us consumers on the left-hand side. We know something about us, where you live, your demographics, how old are you a man or woman, what your behaviour is and your psychology, and I'll say a little bit more about that in a second. But the way you buy things, you have preferences, and the way that you express those preferences will determine how you're actually sold something. And in very simple terms, if you are a retailer or selling, you usually have 2 things that you want to push. It's either the cost of the product, value, or you want to go for a differentiation, a quality product. And what the internet tries to do is guess which one of those customers you are in simple terms, and then direct you to the web page that will make that offering more appealing to you. And that's what internet marketing is all about. So there we are as customers. We have a number of different offers which are usually based on the internet, and what we're trying to do is extract information from the customers to actually direct them quickly to the place they may buy something. And there's an example. I want to buy a broadband package. I type in broadband package, blah, blah, blah. What comes up? Well, there's two offers. You can probably see the top ones, PlusNet, and you can see very predominantly £18.99 per month. So that's very much a cost offer. They're going in at a low price there. And at the bottom, we have the BT offer, which is more about, do you want hyper speeds? Do you want sport? Do you want Wi-Fi in every room? Do you want to be able to connect your phone to your Wi-Fi? You know, they're doing a lot of things. Where's the price on that advert? Very small letters, $39.99. So you can see that what they're pushing is the features. What's the interesting thing about that example? It's the same company. PlusNet is actually BT. And that's very common in marketing. You actually have several personas, and the persona that you have is the one that you're trying to sell, even though behind the scenes you're the same company. So how does that help us? Well, one of the very early examples that we had of this is saying, well, what do we know about the customer? What information have we got about that customer that can start helping us make some sort of decision? So if we don't know their demographics, if we don't know their preferences, if we don't know anything about them, how do we actually guide them to the web page that we actually want? And quite often it's, you know, the landing page is the same. It's just as soon as you click onto it, it sends you off into a sub-page, which is designed for you. And there's two offers, $49 for a travel, which is obviously a cost offer, and the other one is the comfort. One of the early findings was, depending on which browser you come in at, and the receiving web page usually knows what browser you have because of the communications it has, that will tell them something about if you're a value customer or a quality customer. And immediately, if you come in on Safari, you'll be offered quality products because you can probably afford Apple products. You're willing to pay £700 for a phone. If you're willing to pay for £700 for a phone, you're not worried about saving a penny or two. So even with one piece of information, which you haven't actually said you can have, but it's automatically revealed, people are making decisions about what sort of customer you are. And of course that has been moved on significantly, and this is some of the basics of machine learning. I'm not going to talk about artificial intelligence, I'm just going to talk about machine learning. Machine learning comes in a couple of different flavors, and I'm going to talk about some of them, but the first one is clustering. Can we actually say, are there more than one group of people from the information that we've had, even though the information actually might be quite scarce? I'm going to come on and talk about classification and regression. They're my examples. But the unsupervised learning is you just take the data and start to see it as it fit into some sort of pattern. And there's an example which is drawn from marketing, where depending on where you shop, clustering has taken place and you're being given a category. And you can see how Rob at the end, he goes onto the BBC webpage, he doesn't shop very often, he's not likely to pick up a bargain if one's offered to him, whereas I think Isabel is an impulse buyer, so if an offer comes up, she might just press click buy now, so she'll get a slightly different web page. She'll get buy now, this offer only lasts 24 hours, blah blah blah. That clustering is done from information which is gleaned from the internet. How does machine learning work? Well, it all works in a very simple fashion. I'm going to talk about some of the differences between statistics and machine learning later on. But essentially you have some data which you can get your teeth into. You split it into two, so you have a learning set and a training set. Now, this is not a new concept, this has been around for quite a long time, and neural networks have been doing this for donkey's years. You put half the data into a training set, so it has a look at it, and I'm going to show you how that works. Then it goes and compares it with the other set, and seeing, can it predict the outcome in the other set from what it's learned from the first set. So everything we're going to do is take some data, split it into two, train it, test it, see how it works. Now, unlike the sort of statistical approaches where you'd want to have some sort of rigorous thought process behind what you're doing, it's always suck it and see. Does it work? Yes, let's use it. So if you're working in an environment such as marketing, you may want to do this very quickly. Success is selling goods. If you get it wrong, or maybe your profit isn't quite so high, the stakes are not that high compared to healthcare. Suck it and see does actually work in that environment. And that's for something for us to reflect on. Can we go with suck it and see? And I'll give an example about that later on. Right, so let's stop talking about generalities and let's talk about some specifics. I'm going to give you two examples, and they're both health examples. So the first one, A&Es, is something Johnny and I spend some time thinking about. And one of the constant calls on our attention is people pitch up at A&E, should they be there? Should they go somewhere else? Should we put that huge great big sign which Bradford BRI has outside saying go away, essentially? But massive overthinking, do you have to be here, and so on and so forth. So we like to know something about the patients as they arrive. So I've formulated a question which is probably a simpler one to answer, just to test it. So what we're going to do is try and classify patients on available information. See, it's very much like the marketing work. What information have you got? What can you glean from that information that tell you something about that person? So first of all, we're going to have a look at, if someone pitches up at the front door of the BRI, what do we know about them? Can we predict they're going to be admitted or not? I think about 25-30% of patients are admitted, something like that. If you just pitch up at the door, do we know you're going to be admitted or not? Compare that to a doctor guessing. Nothing clinical, just about where they're going from. I'll just give a little bit of background to this. What Azure is actually doing is we're setting up a model which is a sort of one-time process. When we come up with that model, the idea is that you have an input and an output, so you put the data in, an output comes out, and that would normally be embedded inside a web application. So you see this happen all the time, that when you're buying something it says, do you want to buy this book as well? It's doing that sort of algorithm. So this might be, in this example, the receptionist at the hospital will take some of your details, where you've come from, your age, time of day, things like that, and it will come up with a flag saying high risk of being admitted, low risk of being admitted, and it could come up on the screen. And that could be used to streamline some of the patients into a fast track. If they're a high risk of going to be admitted, let's get them in fairly soon. So it's like an automatic triaging process. So I'm going to talk about the bit in the blue box, I'm not going to talk about the web application. Let's start with some data. Johnny has been setting up some test data which is anonymised. So on this test data we've got nothing about patient ID, no HES IDs, nothing, no SUS IDs. We've also stripped out of it actual time of day and actual day of the week. So down on the right hand side I've got day of the week by 1 to 7 from Monday to Friday, month by 1 to 12, and time band by 6-hour blocks, which has been derived from the original time and date. And I've done that in Excel. You can do that in Azure, but it's easier in this case to do it in Excel. So let's disappear out of here. Let's go into Azure. So this is a spreadsheet. It's been saved as a CSV file. So we're now going to get that on the screen. And I'm going to say we're going to do a new experiment. How do we do new experiments? We press that button there. And what we find is there's a lot of experiments which you can start with, which are part of their learning set. So if I went over on any of these, I could open one of the examples they've got, and these should link up with the training videos. Oops. How do I do that? Oops. I'll go back to using emails. There we go. But we'll go for a blank experiment. Yeah, that's fine. So we have a canvas that looks like that, and what it says is we're going to start taking modules, and that's how this works. We have modules which you drop onto a template, we connect them up, and it's in effect a wiring diagram. So there's no coding. You can do coding if you want, but be careful. So if you go to save datasets, my datasets. So yesterday I took that Excel file, I uploaded it, and I've called it demo A&E, and I drag and drop it onto there. We started! That's it! What have we actually got there? These little bulbs here. Has anyone seen any of this before? Or is this all new? If we go onto that, you can always see something inside it. So it's going to say visualize. We're going to have a look at the data set. So that's the data set that we put in. It started off as a CSV file. It's brought all the headers in, and it has this useful little histograms at the top. Why is the histograms useful? Yes. Whenever you do statistics, you want to know, are your variables distributed? Ideally, they're normally distributed, because everything works beautifully if it is. If they're not distributed, if they're just a single value, then there's no point in using it. Go away. So that gives you some sort of, and you can look at this, and you can look at any of these, and it gives you some useful information, so you can say, should I be using that or not? That was easy, wasn't it? Now, the process, remember those corky things. I'm going to come back later and talk about the data, because I think 90% of the problem with this is not doing what we're going to do now, is getting the right data into that block there. And I think that's where all the clever bits come, but I'll make some reflection on that later. So I've done all the clever bits, which took me about 2 weeks last week, and we're going to start doing some experiments. Now, first of all, what we do is we can select columns, so you just put select. Down here we have all the boxes that we could possibly want, and we join them up. Now if we can join them up, if it lets us do that, we're in with a good chance. But it's come up with a little red block there, so I'm going to do something, run. That will probably disappear. You can see it running, because in the top right hand corner it says, we should say running. Run. Why is that not running? Don't know. Let's proceed. What we're going to do here, let's save that for a second.
David, it needs to define which column you want to select.
Well, that's what I'm just about to do here. Because I should be able to run it, I think, at this stage. What I'm going to do is I'm going to select all the columns except for one. So this is acts as a filter. The disposition is, are you sent back to your GP, or you sent an outpatient clinic? So we're not interested in that. Let's just go for that one. So essentially that's acted as a filter. The data started there. All the data is going to go through that, except for the one that we've taken out. We're going to clean it as well, because one of the problems you quite often have in large data sets is clean missing data. Can we join that up? Yes, we can. And then there's some rules for cleaning the data. So we're going to use all the columns. Yeah, we're happy to use all the columns. And what it's going to say is, if there's a missing piece of data, I'm going to replace it with the mean. You can actually just remove columns that haven't got data, but I'm just going to replace it with the mean, because there aren't that many missing columns. And now we're going to do the first bit of the actual. You can do a lot of other pre-processing in here, which I won't go into. You can put modules in here, which run R or Python. So if you want to do some very clever things, then you just drop one of those in. Let Johnny know if you want to do that, because he does that, I don't. So we're going to split data. So what this does is, right, I've got two outputs here. I've got output 1 and output 2. I'm going to split one lot into one lot and the other lot into the other lot. And we're going to do it on a 50-50 basis. I'm going to change that to 7. So 70% go down one lot and 30% go down the other. That's a sort of, depends on how much data you've got. And then I'm going to get into the interesting bit. I'm going to say train model.
So in terms of the split, have you got any configuration? Can you tell it how to split it? Is it totally random? Is it just black box?
That's randomised, because it's randomised split, and you can put a seed in there if you want to reproduce it. If you want to test it many times, you did a thing where you have random things, but you have a predictable random. How does that work? I never know, but yes, you can do some things on that. I think what you should be seeing now is you've got some controls over this, but not very many. So if you were normally doing this in code, you'd have an infinite number of choices. All those choices are being removed from you. I think Johnny's going to say something about that a little later on. So we're just going to join that split data with there. Now we're going to say, well, how are we going to train it? Now, this is a little bit of the dark art. We're going to have a 2 class. Which algorithm you actually use? Classification. What we're doing is a classification 2 class boosted thing I think you're going to use. So what that's telling is, this is the algorithm I want you to use. Now, this is the sort of thing, well, why have I picked this and not another one? Well, as I said earlier, it tends to be a suck and see thing, which I'll talk about when I give the other example. So we're going to train it, and then we're going to score the model. Remember, I said that what we're going to do is run it, test it, and see if it works. So we're going to take the other data set there, and we're going to take that up there. Now, have you noticed that that one, let's come up with that little blob. It's going to say you're doing a training, but what do you want to train it on? So we're going to do column selector, and I'm going to train it on admitted. So you can have a look at that's the dependent variable, which has gone into there now. Almost there, school model, we want to evaluate the model. We want to know, is it any good or not? And I'm going to have an output as well, because I like these outputs. I'm going to convert and get the data back out. And that essentially is the model. Right, how confident are you if I press run, something will happen? Hands up if you think this is going to be an absolute disaster and I'm going to spend the next half an hour trying to work out what's gone wrong. Thank you. Let's press. It should run fairly quickly. There's 130,000 lines of code in this. This is an A and E department run for a year. The data's come from. So that's 130,000. So it's running, there's a little thing up there that says it's got into the queue, it's run. Just a little side issue, when you set this up, it asks you where you want the data to be stored. I wasn't quick enough on the thing. So this data is actually running in America at the moment. You can choose Europe, which is what I should have put, but...
if you get the option UK South, if you don't get the option Europe, if you don't use actual NHS data, it has to be UK South.
I don't think the ML,
that doesn't have UK South.
Yes, I think it's Azure main has that. But, so we only get a choice of Europe or America or somewhere else. But anyway.
David, how secure is the data? Because that's the question. Is it sort of in a site that's generally open, so that you have to watch what you do?
That's the problem I'm K-band.
Microsoft also has some materials on security and cloud for this sort of data. Essentially, if we keep it within the UK, we are secure, and you can see that on the documents. As soon as you start sending it to external servers, things get much more complicated.
So it's run. We've got ticks on all the boxes. What will happen is, as a fault, is it won't get to a certain point. You get a red blob rather than a tick. If you've got ticks everywhere, that took about 30 seconds to run. So let's have a look at this blob and say visualize. Let's score the model. And what this shows us is that's the data that we've put in. The admitted is the dependent variable, and the scored label is what Azure has come up with its machine learning. So if the two are the same, we've got it right. And there's a probability score there. If there's a difference, that one for instance, that patient was admitted and we think they are going to be admitted, we've got it wrong. And the question is it right enough for us to use it, or is it so wrong we wouldn't touch it with a barge pole? And what you find is you go into the evaluate model bit, visualize, and it will come up with this ROC curve. And if you've done any medical diagnosis stuff, you will see this receiver operator characteristics. I think that's ROC. Essentially, if you've got a test and all the results come up on that straight line, it's no better than just flipping a coin. It's just random. The closer that line is into the top left-hand corner, the better it is. And it actually comes up with a little number here. We essentially got 80% of them right, 81% of the ones right. And these are the true negatives, so these people we thought were going to go home and they did go home. These are the people that are true positives. These are the people that we thought were going to be admitted, and they were admitted, and they're the ones that we've got wrong. So that should come up to 80%.
Can you tell it to err on the side of caution by, if in doubt, saying they're going to be admitted?
Not on this one, you can't.
Right.
But remember, there's no medical evidence. The only thing we've got is time of day, where they've come from. Did they come from a deprived area? The distance they've travelled. Have they come by an ambulance? And we can actually look at the algorithm that it's come up with. If we have a look at here, model, visualize, and this will show you how it's come up with those solutions. It will be a nodal thing here. And what it does is, because it's a decision tree, it looks at each of the factors and looks at where the tipping point is, whether you should be left or right or things. And you can't see that. So the biggest factor is, did you arrive by an ambulance? Well, blow me down, I could have guessed that one. Then we start with age. What's your age? And then if you go further down, I don't know if I'm getting further down. You start to get time bands coming in and other things. So these are all secondary things. So it's working in a very logical way, but it's taking the information it's got and improving the way it does it. Are you all happy with that? So what you've seen is we started with a CSV file 10 minutes ago. We've done drag and drop, and we've come up with an 81% prediction of just guessing when you walk into an A&E department if you're going to be in it or not. And you don't need the 12 years of medical training to do that. Just doing it on the demographics. Okay with that? I'm just going to move on. I'm going to give you another example and show how this works in a slightly different way. So that's the import, that's the model. That was the plan, that if it all failed, I'll just show you that. There's that tree that we've got, and there's the results we've got. There's the ROC curve, and you can see 7% of the true negatives you got right, 12% of the true positives you got right, and it's 11 and 7. And this is probably where you're coming in. Would we err on the false negatives or the false positives? Which way is it balanced? And the moment it's erring on the side of false negatives, I think. Let's go for a second example very quickly, just to show how this works. One of the things I'm interested in is productivity of hospitals, and that comes out of the going back to 2009. Hospitals have really got to start saving money. You could say in the NHS they've always been trying to save money. In 2009, David Nicholson, who was Simon Stevens' predecessor, says you've got to find some big savings. And Lord Carter did an investigation, you may be familiar with the Carter Review, and said you can actually save £5 billion if you take some of the variation across trusts out of the system. And NHSI have something called Model Hospital, which tries to pull together a dashboard of hospital performance to help managers understand where their performance is and look for areas of weakness. And that's based around a standardised metric, the weighted activity unit, which is described there. And for those that have been around will know that that is actually based on something that we used to call the RCI, the Reference Cost Index, which is published and is freely available. You can get it off the NHSI website. And some preliminary analysis, each dot there is a trust, and it looks at productivity data for each trust for a 3-year time period. And it's, are you above or below the average? So if you're above average, your costs are, I think it's the other way around, it's negative. If you're above the line, your productivity is better, and so your unit costs are lower. And if you're below the line, it's higher than average. And if you go from left to right, it's, are you getting better or are you getting worse? So is your productivity falling year on year, or is it improving? And we're looking at trusts in zone 4, the top right hand corner. They're better than average and they're getting better. Trusts in the bottom left hand corner in 1 are worse than average and getting worse. So these are the ones which NHSI really are interested in. And the question is that we asked is, can you, from a dashboard of information that a executive is offered, know where you're going to end up? So if you're in April of the year and you're managing your trusts, are you getting better or worse? Or from the information you've got, do you know you should be looking for another job? So we're going to use supervised learning again, but we're going to have a look at a regression model rather than a classification model. We're going to say, can we actually predict the current year's productivity figure from historic data and dashboard information? So extracted some information, another spreadsheet, and you can download this. This is embedded in this slide pack, so if you get this slide pack off of SharePoint, click that and the spreadsheet will actually open. So there's all acute trusts in there. And what we're going to do is, this is selecting the data and running through the machine again. So if I'm going very quickly, about 10 minutes to do this. I'm going to have a look at doing my experiments. New experiments, blank. So you should recognise all this. So it should be demo hospital data this time. So we visualise it. There you go. And what you'll see is that we've got, this is the dependent variable, cost per activity unit. We've got last year's value. We've got the change, the trend. If that's positive, it's going up, and if negative, it's going down. And we've got a whole range of information which you could normally expect. This is all published data of various different web pages, which we would normally put into a dashboard of the current year, or how the trend has gone over the previous 2 years or the previous 3 years. So that's the data we're putting in. So lo and behold, what we're going to do first, we're going to
select column.
What columns do you think we're going to select? Let's go through all of them. I've actually stripped out all the ones that we're not going to use. So we're going to just select everything on into that. Yes. We're going to select everything. And it will say, what's the next one we're going to do? Clean it. Because there are some missing data. Clean missing data. And what rule are we going to apply? We're going to use all columns.
Me.
Let's go for mean. That's what we did last time, isn't it? So let's go for it again. So you've got a whole series of things that you could put in there. What we're going to do next? Split. See, it's so easy, isn't it?
Don't we have any categorical data?
No.
Okay, just checking.
Yeah.
You know, shoving a.
I've taken that out.
Thank you.
Otherwise we might be here a bit longer.
Sorry, what was the splitting part doing again?
So-
What was that, sorry?
Test versus training data.
Oh, right, okay.
What sort of splitting shall we use? This has got a lot of smaller numbers. Remember the last example, they only had 130,000 lines. This has only got 190. So that would be an influence about how you're going to train it. What did we use last time? Let's go for 0.7. This is something you can play with on a sort of experimental basis. What did we do next?
Select the model.
Yeah, let's select the model. Now, any idea what we're going to select the model? Because we're trying to predict an absolute value. It's not going to be a categorical or thing.
Maybe what type of regression?
Yeah, what sort of regressions would you like me to use? Oh, let's have a look down the machine. It's probably called something else. Machine learning, regression, linear regression. There you go. We're going to train. Is it train model next? Oops. Why have we got a red dot there? We haven't what?
Because you haven't connected up the data.
Ah, well, let's see. Yes.
Actually,
Red dot's still
select-
there.
Select columns.
If we're going to train it, what are we going to train it on?
What's it saying? Select which column.
Yes. So we need a dependent variable, and it's going to be this year's cost. So you can do this. It's really, what do we do next? Evaluate, yes. Oh. Oh. We can't evaluate it. What do we do next?
Something to do with outcome or something.
Score. Oh, you know this. See that. Oops. Let's move that over there. It allows us to do that. It wouldn't allow us to do a non-permitted thing. Evaluate model. What else did I do?
Export to CSV.
Export. It's convert, I think. Convert. So you can just look down that whole thing, but if you just type in that, then it goes. Right. How confident are we? I gave you this bet last time. I said, how confident are you that we're going to do this and it's going to work?
No red marks.
Aye. So it's gone off to America, big server somewhere in California, scratching its head.
It shows you how far each bit's
Mm.
done as well.
So, have I got time for a cup of tea? No, I haven't. I've got to sit next to this one, haven't I? It's not like some of the models we do where you can have a good chat for 10 minutes or just peruse the internet or something. There you go. So it's done it. Let's have a look at. Let's have a look. It's score model. Let's visualize. So if you remember, what this is going to do is that's the output variable. 3691, and that's the value that it's actually come up with. That's the regression to 1, 2, 3, 4, 5, 6 decimal places. I don't think we need 6 decimal places, and we can visualize the score. This is a little bit more complicated because this gives us a average deviation, and those are the average deviations from the value, and we've got a 70% coefficient of determination. So that is not particularly bad, but what I'm going to do very quickly is I'm just going to download the data, show you what I would normally do. This is a lot quicker than the last one, isn't it?
No, you're saying about going away and making a cup of tea. So, if you do leave it running, it's working in America.
Yes.
And let's say it's going to go overnight.
Yes.
So you just got to log back on and the results will be there. The
Yeah,
same stuff as it goes.
It auto saves it as it goes along. You never lose data because you've forgotten it or it's disconnected or anything like that. Because it's all over there, it's always saved. And where is it? Just, should be there. Did I press the wrong button? Try again. Save as dataset. Download. Open. Allow. Oh, there we go. Must not been paying attention. So that's all the data in the. This is not all the data. This is the data that hasn't been used for the learning. This is the sample test data. So this is the scored label. So that's what the machine learning has come up with. Let's put this into an XY chart. Let's select data and edit it. I'll put it as a label. Let's see what the real value was. Oops. Move that to this is tidy that up a bit. So you can see we've got a bit of a line there. Can you tell me that? Format the area. Oh, no, I don't. Let's add a regression coefficient. And look, lo and behold, there's the 0.71. So that's the number that it was telling us it was in. So we've got an R squared of 0.71 there. That's, quite plausible. It's, it's not bad for, above 0.8 and I'd stop believing it. I'd say it's an artifact, and below 0.6 I would say try again. So it's in the right area. So what that's telling us is, if you're a manager, you've got historic data, you've got a dashboard of data, you can predict what your year-end productivity value is to a confidence of about that level from the data that you've got, and that can be automatically updated, which is management information extracted from a dashboard, which I don't think we can do that at the moment. I won't show. I'll just show you. I'll open one of the other experiments, which will just show you what you normally do. These are all my saved experiments. If I can find it. Cross-validation. That's what I did today.
Do you tend to use this exclusively now, outside of code-based tools now?
Well, I used to use SPSS, and I've lost my license to SPSS, so I have to use this. If that's an honest answer, I'll edit that out in the video. That's not the one I wanted. Experiments. My experiments. Bear with me for a second. That one. What I'm trying to show you, and I might have to resort to the slide, is what you can do is test two approaches and see which is the better. And that's, no, I haven't got it, can't remember where it is now. What you essentially do is split the data and reproduce all this. So when you get to the evaluate model, it says the regression model comes up with this answer, the neural network comes up with this answer. Which of the two do you want to use?
I must admit, we have this that functionality in Enterprise Miner in SAS about you construct it and construct it with then multiple ones, and then you have an evaluate and comparison piece.
It's. I think this is a philosophical point that if it is a suck and see method, does it work? So let's use it. That's fine. But if you don't understand why it's better, then how much business are you going to actually base on that? Anyway, that's.
You shouldn't be doing the work if you don't understand the stuff.
I couldn't possibly comment.
Okay.
What that model also said, there's the regression. Oh, I've got a slightly better regression than I did on that one. This is actually the model values that it's come out from the regression. Some of the things you would say are reasonable predictors. The biggest one is the percentage day case surgery, which was a bit of a surprise to me. That seems to lever a lot of productivity. What you see here is if it's a positive figure, remember more cost is bad, less cost is good. If you look at the change of doctors, that is forcing the productivity to be better. If you change the number of nurses, that actually goes in the opposite direction. So you're adding cost, but not productivity. Now I'm not sure that is widely appreciated yet, but that's one of the implications coming out of the model. And if you look down at consultants, they also have a negative effect. So the more consultants you have, the less productivity you have. So one of the messages that are coming out of this, if you want to lever your productivity, you put your money into your junior doctors, because that's where your productivity is coming. Now it's not actually counterintuitive, but it's the way in the opposite direction the NHS has been running for a number of years. We've been increasing the proportion of consultants over junior doctors. What this model is now saying, you've got to start reversing that trend. Now if that's true or not, I don't know, but that's a finding from analysis that took 20 minutes.
Yeah.
And I didn't spot that before. But that's what the machine learning is saying. Have a look at that area, you might find it interesting. Final thoughts, just coming up to the hour. Old dogs, new tricks. Should you all be a statistician doing this? Well, I think that's an argument. I said originally, what I've found is 90% of the heavy lift is deciding what data to put in. What you haven't seen me do is do some manipulations with the data. In particular, I've actually put some slope data in there. So in that last model, it's not the absolute number of doctors over the 3 years, it's the rate of change of doctors. Now that might not be intuitive to a lot of people, but that comes out of that matrix that we showed first of all, and that seemed to have picked it up. So, I think Johnny's going to say a few words before I go. This ML is very much the entry level. What it's meant to do, I didn't show you this, but there's a button at the bottom that says Web Enable. It takes your model and it puts a top and a bottom on it to allow you then to connect to a web page which is in the main Azure site. So you send it data, it sends back the results. It's just a system like that. There's a whole series of other things that Microsoft do, which does more of a heavy lift code version. Dr. Watson, as I mentioned, IBM bought SPSS and Enterprise Miner and all that lark. They are big in this sort of area, but they don't seem to have such a simple entry level. You seem to need to know quite a lot before you get there. And MATLAB are also quite big in the area, and a lot of the documents that are embedded are from the MATLAB web page to help you understand, but that's all coding. That looks very much like Python, and so you can't just do drag and drop, you've got to start writing code. So as everything, I would say yes, the tool's excellent and it's come up with some good examples, but how much is the craftsperson, me in this case, and you when you do it, and how much is it the tool, and how much time do you actually spend learning how to do this? So the very last thing I'm going to say, because this document is meant to be a standalone document, what you find is those two documents that are embedded there are the way that you select which algorithm you're going to use. That gives you some more background and information into that. Down the left-hand corner, that's the Azure handbook, which has got other examples like credit scoring and things like that. It's quite a long handbook, so if you want to follow this up, that's a good thing to print out and start using. And the very last thought I'll leave you with is the bottom right-hand corner is a paper from America about using an artificial intelligence approach to predict death. What it's basically saying is, at the moment we trust doctors to decide when you're on a palliative care route. Essentially, if you're on palliative care, no more treatment is going to be offered to you to cure you. You're only going to be offered care to manage your pain and to give you best support up to death. And doctors are biased in their decision about deciding when you're on a palliative care. They always want to try that little bit harder. So what this is saying is, do you need the machine to put the hand on the shoulder of the doctor to say, don't try anymore, it's going to be futile. Palliative care, please. So, I don't know, it's not the sort of thing I would like when I go to see my doctor and they say, the screen's telling me
The new clinical decision support unit, yeah.
Palliative care only, mate. And I say, where do I appeal? I don't know, I want a bit more treatment. But that's the sort of, it's good paper, it's worth reading, but it does bring out where we're going to end on this journey. Right, that's all I want to say. Do you want to say something, Johnny?